Hi, this problem we're going to look at a webwork problem for 2D equilibrium. So this is a truss and there are forces acting at C and D, FC and FD, and they give us the dimensions and forces in this table here. They want us to find the moment of those two forces created about adjoint A and B, and then find the reaction forces at the supports. Okay. So now let's think about how we go ahead and solve this problem. First one, they want us to find the moments that those two forces creating at the joint A and B, right? Okay. We can go ahead and start with that. So if we're going to find the summation of those forces rotating, and so basically they want us to, I'm actually going to write down like this: moment of FC rotating about A, and also moment of this FD rotating about A, right? That's what they are solving. Ask us to solve first. How do we go about? FC rotating about A, and it's applied as C here, right? So potentially what I'm going to do, I'm actually going to move this force in the same direction and have, to be clear, starts as C because it's applied as C. And then this force, obviously it's in an angle, so I'm going to decompose to X direction and Y direction. Then if you look at it, this FC at X direction going through point A, so the moment will be 0. So all we need to worry about is just FCY rotating about A. So let's go ahead and solve this. And we already know this force is at X direction rotating about A, that's 0. Then we just need to figure out FCY rotating about A, right? Then let's go ahead and look at D. Same thing, I'm going to extend that and apply at D. Then we decompose to X direction and Y direction. So this will be our FDX and our FDY. Okay. Okay, now we're ready. So solving this first, FCY rotating about A. FC is given 4.16 kips. Kips means 1,000, right? Kilopounds. And then the angle here. So this angle is going to be your psi, right? So if that's the case, your FCY is going to be opposite of that angle. So that would be sine. So it would be FC times sine psi. Then the moment of arm is going to be this distance for FCY. That's times A. And then think about rotation. This force rotating about A, that calls clockwise, so that's negative. Okay, now move on to the next, FDX, right here. FDX, we're going to consider about the angle again. So if this angle is theta, this angle is going to be a theta. And then FDX will be opposite of that angle, so that would be sine. So it will be FD times sine theta. So knowing that, we are going to figure out the moment of arm because it's force times moment of arm. Moment of arm for this will be perpendicular to that force. That will take the D dimension, right? And now think about the sign. This force is going this way and it's rotating about A, and that's counterclockwise, so that's positive. Now let's look at the last one. FDY. F dy is going to be cosine, right? Fd times cosine theta because it's adjacent. And now thinking about moment of arm, first you extend this, then you draw. I'm going to use purple. So from A to this force and perpendicular will be that distance. That will take in the dimension as C. And now let's think about this force rotating about A. That's clockwise rotation, so that's going to be negative. So all of this together, that will be able to help us to get this moment A. That is, find the moments that those two forces creates about joint A, right? And you will likely get the answer in kips, and you might have to change that times 1,000 to change to pound. And the units you're gonna get, if it's will be pound force times foot, right? After you change kips to pound force. Now let's go ahead and solve MB. So for MB, again, it's going to be those two forces. However, we're rotating at different points now, right? We're solving this. I'm going to erase all those right here. Okay. So what do we have for this FC rotating about B? FC we already decomposed to X and Y. And X direction will be FC times cosine phi. That's for this direction, right? And then let's think about you're now rotating about B. Well, what happened? It's also going through point B. It's on the same line. So that's times 0. That's again 0 for Fx direction. Now let's think about Fy direction, Fcy direction. That will be our Fc times sine psi. Then it's this force rotating about B now. What would be the moment of arm? Would be this distance. That would be times B. And the rotation, this force rotating about B, that's counterclockwise, so that would be positive. Okay. Now let's move on to FD. First, look at the X direction. X direction of this force is going to be sine, like what we did earlier, FD sine theta. But so it's this force, but now we're rotating about B. So we'll extend that force. The moment of arm will be D. And this force rotating about B creates a counterclockwise, so that's going to be plus. Now we're thinking about the Y direction. Y direction is FD times cosine theta. But what would be the moment of arm? So it's this force rotating about B. And the moment of arm would be from here perpendicular to that force would be that distance. That distance will be what? Not something you can find out really quickly, because if I make it clear, it's gonna be what? It's gonna be this entire length. So we're trying to figure out this distance right here. That will be same as here. This will be A plus B, this entire length minus C, because the top one is A plus B, you have to minus C. So hopefully you see that. So that's going to be A plus B minus C. Now let's think about rotation. We're on FDY, it's this force. and rotating about B, that creates a counterclockwise rotation. So that's going to be positive. That equals 0. Woo! So you got if you put all those in there, you're going to get change kips to pound, then you're going to get unit of pound-foot of this. Okay. So that will solve your first two problems. Then the last one, reactions. That's actually where I want to focus on, but I think it's actually easier. What I'm going to do, since this is so labeled up, I'm going to delete them. And we're going to draw our FBD. For this FBD, we have two forces already, FC and FD. But A is a pin support, so we'll have AY, and it also will have AX. And B, it's a roller support, so it can move freely at the X direction, so there will be no BX. However, we'll have BY. Those are our three unknowns. And we have three equations. Then we can solve it. So in order to do this, first equation, forces at X. What do we have? We have AX. Then we have FC have X direction, right? Again, if I go ahead and extend this and decompose, that's my X and Y. And this is angle, psi. Same thing, I'm going to do FD. And decompose. And we know this is angle theta. Alright, so for FC direction, we'll have FC times cosine psi. And this is going to the left, so this will be minus. The FD also have X component, and the FD component is FD times sine theta. Because this angle is theta, so this angle is theta. It's opposite, like you did in the problem right here, right? And it's also pointing to the left, so that's negative. All those add up to be equal to 0. Because BY is strictly a Y direction. Now let's look at our Y direction now. Y direction force will have AY, it's going upward. And FC have Y component, it's going to be FC times sine psi. And that's going downward, so it would be negative. The FD also have Y direction force, and that's cosine theta, and it's also going downward, so it's negative. Then we'll have BY, that's going upward, that's positive, equal to 0. Then we're going to look at our moment. What do we do moment about? Obviously, we're going to do moment about A, right? And if you already figure out this problem here, only this one moment A, you can use this answer right here to put it in here, because in that, you already consider FC and FD, right? And then you can just solve the rest of the force rotating about A. First force AX, AX won't rotating about A. Second force AY rotating about A, that's also equal to 0. That is the reason we're choosing point A. Has a lot of forces on there. So AX and AY will not show up in this equation. So the next one would be FC rotating about A, which is right here. You already have a, you can write it down. So I'm just say FC sine A. Then the next force is going to be your FD rotating about A. FD rotating about A. It's all those two together, which is right here. FD sine theta times D minus FD cosine theta times C. All right, so far you consider AX, AY, that equal to 0, the moment about A, and then you also consider this. This is going to be your moment of FC rotating about A. this together is your FD rotating about A from the previous problem. Now the last one is your force BY. BY rotating about A, that's straightforward, BY. BY is vertical, so moment of arm is going to be this entire length, that's A plus B. Now consider the direction. It's going to rotating about A counterclockwise, so that would be plus, that equal to 0. Then again, thinking about there are 3 unknowns, right? The rest is known. Those 3 unknowns are your AX, AY, and a BY. So put them into your linear equations, then you can solve them. You can find your AX, AY, and BY. And that is going to be your AX direction, AY direction, and BY direction. Okay. All right, so that's all for this problem. See you next time. Bye.